Hi everybody, today I want to go over some tips for making mini lectures for students. The first thing I want to talk about is the length of the video, and I want you to think less is more. Ideally, videos should be 6 minutes or less when possible. You can make videos that are 10 to 15 minutes long for more complex topics, but when possible, we want to break up the information into smaller chunks to keep students on task and make sure they're engaged with the material. So let's start talking about the structure of the video. The first thing I want you to do is have a plan. Maybe make an outline of what you plan to discuss, which should include some visuals to keep students engaged. Consider the clarity of your handwriting. If your handwriting is hard to read, think about typing out some or all of the content. If you're going to type things up, maybe you're going to do a PowerPoint slide like I'm doing, remember to give a little bit at the time. Make sure you're reading everything that is on the slide. We want to make sure that anyone with visual impairment doesn't miss out from any of the information. When possible, be excited about the content, engage with it, show students why it's important. You might want to animate the information, which means add a little bit at the time so that students aren't overwhelmed by looking at a slide full of words. If you are working through problems, make sure you are showing the steps. Remember, students are in the learning stage, so just because we understand all of the steps doesn't mean that they also understand the steps that we need to go through to arrive at the answer. Don't show all the work at once because that can be overwhelming. Instead, show each step of the calculation to ensure that students don't get lost. Let me give you an example. Say I wanted to solve 3x squared plus 8x minus 2 equals 0. My first step might be to tell students that we're going to use the quadratic equation. I want to remind students what the quadratic equation is. I don't want to assume that they know the quadratic equation. So I would put on the screen that x is equal to the fraction, negative b plus or minus the square root of b squared minus 4ac all over 2a. Then I would want to tell the students what a, b, and c are in the equation that we're solving. So I would make sure they know that a is 3, b is 8, and c is negative 2, and I would probably emphasize the negative to make sure they know that the sign stays with the number. I would then take those values of a, b, and c and plug them into the quadratic equation so that students would see that x is equal to the fraction negative 8 plus or minus the square root of 8 squared minus 4 times 3 times negative 2 over 2 times 3. I wouldn't just leave it here. I would do the next step, which says x is equal to the fraction. Negative 8 plus or minus the square root, well, 8 squared is 64. Negative 4 times 3 times negative 2 is 24. And then 2 times 3 is 6. From there, I would tell students, well, remember, 64 plus 24, we can add those together. So now 64 and 24 is 88. I have this fraction. X is equal to negative 8 plus or minus the square root of 88 over 6. How would I reduce that radical? Well, 88 is 4 times 22, so that I can take the square root of 4, which becomes 2. This simplified step is x is equal to the fraction, negative 8 plus or minus 2 square root of 22 over 6. Looking at negative 8, looking at 2, looking at 6, I see they're all even, so I'm just going to divide everything by 2. My final answer would be x is equal to the fraction, negative 4 plus or minus the square root of 22 over 3. So I have shown each individual step. Hopefully students can follow along and they know they can stop at any time if they need to look at it a little closer. I also want to remind you to model technology usage. If your class uses software that students must also use, you want to show them how it works. Share your screen, walk the students through the steps. When possible, add arrows and other notation when you edit the video to help direct students' attention to the proper buttons or links to click. Clicks are fast, clicks are easy for us to do because we've done it a bunch of times before. So we really want to over exaggerate the uses of technology so that they can grab onto what we're doing. So here's an example where students need to graph f of x is 5 times x cubed. It tells them to show 3 graphed points and the cubic function. That might not be clear, so in my video, I would want to show them an example of that. Students aren't going to get this exact problem. They get different numbers. It's algorithmic, so I'm just modeling how the technology works. So the first thing they have to do is pick the parent function. So here's the cube. And then they're going to graph the cubic function for 5 times x cubed. So they put in a point, and the second point gives them the shape. Now, they have to have these 3 points, so they need to grab the point also. and then they need to click 3 points. So here's 1, here's 2, and then here's 3. The couple of seconds it takes to show the students technology will save a lot of frustration and also reduce the number of emails that you get when students say, I don't know, I'm getting this wrong. Know that when you're making a video, it is okay and normal to make a mistake. You can edit them out. When you make a mistake, just keep going. Repeat what you were saying and cut out the mistake when you were done. When you rewatch the final project, you'll be able to make the nice edits and have a nice professional looking video. When you can, add closed captioning to increase clarity. Closed captioning is really important for any students who can't hear everything we're saying, but it also helps when students are unsure of what we're saying. Lastly, remember to ask for help from colleagues. We all have experiences and trial and error. We know what works, we know what doesn't work, and it's really great when we collaborate and share.